Hello, this is example 3. Draw the shear force and bending moment diagrams and label values at points of interest for the following cantilever. And don't take into account the weight of the beam, so ignore that. So this example is different from the others. We solved one example with 2-point loads, second example with 1-point load and UDL. This example, 1-point load, UDL, and there is a moment around this point, 4 kilonewtons meters. So step 1, free body diagram. You show the AY and AX and the moments MA. Summation of forces in the X direction, AX is equals to 0. Summation forces in the Y direction, AY is equals to 13 kilonewtons. And then moments MA, because we assuming clockwise is positive because the moments rotating on the opposite direction will be minus 39.5 kilonewtons. Now, if you want to solve step 3, which is the shear force diagram, shear force units is kilonewtons. What we have, we start with a line representing the AY value, which is the straight line of a value 13 kilonewtons, but we don't need to specify the units. So we bring this one here. We say 13. And if you look carefully, from that point, you continue straight till the 10 kilonewtons, which is taking me down with a value. So it will be 13 minus 10. The remaining is 3. And then I'll put the value here to indicate this is equals to 3. And then from here, I will continue straight line till I reach to the UDL. And then that UDL would go as a slope downwards, which is 3 minus 3. And that will give me the 0 value. And then the remaining of that will be just the 0. So I just need to be careful here and to show there is a 0 started from this point, okay? So that's the shear force diagram, which is very identical to what we show in the previous example too. Just we want to show that in more detail. So here I will show the positive area here. And I need to say I have a positive area 1, and this is also positive area, and I'll explain why, and positive area 3, and positive area 4, which is the triangular. Why I divided this to 2 areas? Because that's where you can see this line indicates for me where is the moments happening. Therefore, I break this one to 2 areas because I need to take into consideration the effects of the 4 kilonewtons moment. So now let's try to draw the bending moment diagram. So 4, it's bending moment, unit is kilonewtons meters. Because of the moments area is negative, therefore I will go with a negative value here, and we just write that value to be equals to negative 39.5. So I'll write this on the side so you understand what we're trying to achieve here. So it will be 39.5, and that's plus what we have. We have that positive area, just this one, which is 13 times the distance from here to there is 2 meters. And that will give you equals to minus 13.5. So now I need to go as a slope line to that point. So from here to that point, which a value of minus 13.5. And now I need to go to the second rectangular. So minus 13.5 plus, because it's a positive area, what do you have is 13 minus 1. But before that, what's interestingly, I cannot do that. So this should be 13.5. Now also I have a negative 4 kilonewtons minus 4. This will give me minus 17.5. Now, where are you saying where this 17 comes from is just indicates to me that there is a push of that moment in the negative direction. This will bring my moment to go up a bit of area here, maybe around this point. Oh, this one is just indicating for me it's not going as a straight line. So be more precise. So if this was 13.5, then I went in the negative now, kind of increase to 17.5. Now 17.5 minus 17.5 plus the area, which is 13 times the distance is 1 meter, so that will be remaining minus 4.5. So now I go back again as a slope from that point to go back to very small value, which is minus 4.5. This is very important to solve when cantilevers, when you have moment acting in some point. So that's negative 4.5. Now here, so minus 4.5 plus, because it's still a positive area, what do you have? A 3 times 1. And that's equals to minus 1.5, similar to the previous example. So I'll take this value and control and then bring in here. So technically that one should goes as a slope. So I should have something. It's very difficult to do that, to be honest with you, with a small size of space to work in this kind of applications. So it should be just going like very, very tight slope, and we can hardly see it. But it's not going to zero. That's the tricky thing of it. So it should go technically. It's very difficult to achieve that with this kind of curve. So it should come from here and then come to that point, escape with a value. So if I highlight that one, with a value of 1.5. Now, we came again, minus 1.5 plus half of the base, which is equals to 1, times the height, which is 3, and that will lead you equals to 0. So after that, from here, I need to go to 0, and that's where it will be my 0. And then from here, I will continue moving 0. That's how the bending moment diagram looks like when you have a bending moment in between them. So it's very important to take into consideration the 4 kilonewtons. I'll explain this very quickly now. So first of all, we have the minus 39.5 kilonewtons going downwards because of the direction of the moment. And then we take the area till this point. So 39.5 plus, because of positive area, 13 times 2. This is 13 times 2. It will give me minus 13.5. I got a negative moment as well. That's pushed me in that direction. So minus 13.5 minus 4 will give me minus 17.5. Now I come to here, I have a positive area, so minus 17.5 plus 13 times 1, and then that will give me minus 4.5. And here will be minus 4.5, but actually that one should be not curvy, actually. The curvy should be here. So we should change that line with that line, and that one will come here. So that would be a slope going there, and that will give you minus 1.5, and that's one where is the curve because of the slope of the shear force. That will be a quadratic function goes to 0, and this will end up with going to 0. So where is the maximum bending moment? The maximum bending moment is minus 39.5, and the maximum shear force is 13 kilonewtons happening in that position. So if something will break definitely at that line, because that's where is the maximum bending moment and the maximum shear force. Thank you.